Okay, guys, today we're going to talk about properties of multiplication and addition. And we're also going to talk about combining like terms. So the properties we're going to focus on, this is going to be a review. There are going to be three properties. The commutative, associative, and the distributive. You've heard these all before. Raise your hand if you forgot what they mean, because you probably do. It's cool if you do. Anybody forget what these mean? Yeah, I bet. Or as a cool kid in the hall would say, bet. Okay? So, here's how you remember these. What the word means in the English language translates real well to what the word means in math. What does it mean for someone to commute?
Go.
To move, they have to go somewhere to work usually. Right? I have a morning commute or something. So the commutative property means A times B is the same thing as B times A. If they move, it's the same if it's addition or multiplication. Do you see how I could use what commute means to understand that? Then you don't forget it. Associative property. What is an associate of somebody? What does that mean? Lucan.
Someone that works with another person?
Yeah, in your group, right? So what associative property means is if you have A plus B plus C, it's the same thing as A plus B plus C. Changing the grouping, changing the association does not change the answer. Pretty much what these two things together mean is, if it's all add or all multiply, do whatever order you want to make it easier. All right? That's really what it means. But an associative property, grouping. Cool? Easy to remember if you think just what is an associate, I think. Distributive property, what does it mean to distribute something?
Divide it.
Yeah, like handing it out?
Divide it between people.
Okay, so if I have A and a B plus C, that means I'm multiplying B plus C by A. So that's AB plus AC. The A's getting like handed out to all the term.
Wait,
And we saw that in the zombie problem, right? The 5 emergency packs. So that's distributive property. You can remember that is because it's like handing it out. James? There's some ways in which you would want to use this, okay? Let's say you have a 5 plus 7 plus 8 plus 5. If I'm adding that up fast in my head, I'm using what I know of my properties. I can move around and regroup since it's all addition. I'm going to say, here's 10, here's 15, for a total of 25 without doing any extra work, right? You guys see what do you see by not going in order, it's way easier? Okay? Or if you have something like 4 times 12 times 25, I'm going to do 100 times 12 is 1200 because it's way easier. So don't worry about writing all this down. Just look to use different orders to be quicker, okay? You also, next thing I want you to make sure you get down in your notes are what a like term is. And we talked about a second ago. Two qualifiers to make something a like term. Same variable or lack thereof a variable, right? Like 5 and 12 are like terms. They have no variable. And then they have to have the same exponent. To be like terms, they have to be same variable, same exponent. And you can only combine things that are like terms. So if those two things are true, you can combine the terms. So from our zombie thing, we had like 2 bottles of water, a bottle of water, 6 bottles of water. What could we do with all those waters? We did not combine the water with the spoon to make a spotter. Okay? They had to stay separate. How we know different terms are separate? If they could have the same variable but a different exponent, they would not be able to be combined. So only like terms can be combined. So let's look at some stuff. What about 5x and negative 4x? Are those like terms?
Yes.
Okay. What about 2x squared and 6x? No. So it has to have same variable, same exponent. Cool? You get what I'm saying on that? What about like a 3ab and 6a? No, those terms don't have the same exponent ab. Okay? Does that make sense? Or same variable ab, not exponent. Same variable, same exponent to be combined. So for our first example, we're going to do 8y plus 6 minus negative 12y minus 9. Okay? So the first property I need to use to simplify this expression, right? We're not solving an equation. There's no equal sign. We're not going to have y equals number because there's no equals. The first thing I need to do when I get something like this is I need to distribute this negative. See that negative right there? Because I'm taking away everything in those parentheses, right? So everything in that parentheses is going to turn into its opposite. I can treat that negative like a negative 1. In fact, some people like to write a negative 1 there. I don't, but you can. So I'm going to rewrite my expression as this. I distribute that negative. My negative 12y becomes 12y, and my negative 9 becomes positive 9. Everybody good? Because if I'm taking all that away, I'm taking away negative 12, and I'm taking away negative 9. Let's write it as plus instead of minus negative, right? Titus?
I still, wait, so you're adding the negative to the...
I'm multiplying, right? I'm taking all this away. So that would be, if I'm taking away negative 12, that's minus negative 12, right? If I'm taking away negative 9, I'm minus negative 9. That's just adding, right?
Yeah.
So when I rewrite it down here, I'm just going to rewrite it as adding instead of minus negative. And then organizationally, something I like to do is I like to underline my like terms with the same number of underlines. Kind of brings my eyes to these things are like terms. Because if they're like terms, what can I do? Right now it's a big list. I can tighten up my list, right? So there's 20y and 15. And let's say these two things give you a hard time understanding how to add. 8y and 12y. You can say something other than y. You can say like kittens. 8 kittens and 12 kittens is 20 kittens, right? And then if you're doing a test, here's something really cool that you can do. Y is just a number. You could say like y equals 3. And if you were to substitute y into this expression and this expression, what do you think would be true about the answers? They'd be the same. We didn't make a new number. We made a simpler expression.
Indeed.
So the value up top here is the same as the value down here. This looks like some like John Gruden on TV football thing. I'm liking this slide. I'm digging it. All right? What property are you seeing we have to do here? Distributive. Because if I can get it to be all add, I don't need to worry about the parentheses. So 3 times 2x is 6x. 3 times negative 1 is negative 3.
What?
I just distributed this 3 to the 2x minus 1 here. Okay. Next, I'm going to identify my like terms. And then I'm going to combine them. If I have 3 pandas and I add 6 pandas to that, how many pandas do I have? 9 pandas. I'm just saying pandas instead of x because for some reason, I guess if you're doing minus pandas, that means they're dying or something. But, okay. And then I got a 4 minus 3, which is 1. What's true about the value of these two expressions? It's equal. Which expression would you rather work with, 9x plus 1 or that 1 up top? Yeah, that's why we simplify, because math is communication. There's also efficiency in math that we can find a lot of times. It's an opportunity to be efficient.